I promised that we would see what asynchronous test looks like. So we'll actually write an asynchronous test. An asynchronous test, keep in mind, is not a unit test. It's not guaranteed to pass. The network could be down. But here we'll write an async test to test our API endpoint and see if we get back some sort of data. Okay? So go navigate to your recipe search API test. Navigate over to your recipe search API test. It's inside the recipe search test. Click on your recipe search API test, and we'll write our first asynchronous test. Again, an asynchronous test is not fast, it's not reliable, it doesn't qualify, it does not qualify as a unit test. A unit test should be fast, reliable, right? Isolated. This test is not isolated. This test, it requires a network connection. Everybody with me? Okay? All right, so let's go ahead and write that test. I'm inside my recipe search API test. I'll write a function. It's called test Christmas cookies. Okay. For our arrange part of it, we have a search query. Our search query is the actual item we're searching for, right? So that's basically the queue part of it, the queue part of the params. The queue part of the param. So if we go back to our Postman, we want to do a URL very similar to this. We want to have the query, which is queue here. We want to have the app ID. We want to have the app key, the from, and the to. We want to model all that stuff in our actual test. Okay, so we have our search query. What does it take in? Well, we got Christmas cookies. Okay. We got Christmas cookies. There's one other thing we need to do here. This is a string. It has a space in there, but it is not user-friendly or it's not URL-friendly. If it needs to be URL-friendly, everywhere we have a space, we need to encode it with the %20 symbol, right? So we need to add that in. If we have a string coming from the user, if your user puts it into their search bar, Christmas space cookies, and you try to send that as a URL, it will crash. Because remember, a URL doesn't have spaces. You have space, it's going to crash. So to avoid that from happening, we'll encode our string. Anywhere there's spaces, we have a function on it called add-in %. We'll add that particular %20 everywhere we have a space. Yes, question? In Postman? Which search you talking about? Oh, the underscore is app underscore key, you mean? No. Your search is a placeholder. No underscore there. That would be one word together. The underscore was showing an illustration of just a placeholder, right? Cool. So we have on your string, on any string, you could say add in % encoding on any string. Here we want to make that particular string. Everywhere we have a space, we want to add in %20. So you type out add in % encoding. That's a function. That function takes in some argument. We have an enum here. So I could say URL host allowed. This is what I'm after. Make it URL friendly. Make this particular string URL friendly. That's all that's happening here. So convert string to a URL friendly string. Okay. For purposes of illustration here, I'll first unwrap this. I know exactly what I wrote in, but if we're doing our code, we know we need to check if there's actually a string in there. But here we know we have a string. Great. So next we have an expectation. This is the big difference between the test we've written and the test we're about to write down. With asynchronous tests, you need to have an expectation. When is that thing done? Because remember, we have a completion in there. We have a completion handler in there. So when is the thing done? With XC test, it gives us a description of when that particular object is done. So we need to explain what that object is with an XC test. With an XC test expectation. So XC test expectation is a basic string. It's just a string to let us know when the object is done. So here we say description, and we pass in, what are we looking for? So search is found is fine. You can put in any string there you want. Next, we need our endpoint URL. We'll call it recipe endpoint URL. It's a string. Do I have it? No, I don't. Cool. So let's construct that string. I will go to Postman. I will copy the URL. Make sure that you get JSON, by the way. Copy the URL that you got JSON from. And go ahead and paste in the URL into that string. And we need to do some work there. Because right now we need to remove our API key. We don't want that to be on GitHub. Right? So let's go ahead and fix that string up. So where it says app ID equal, do we see app ID equal? We remove app ID, we remove the ID here, remove the ID. So remove after equal and before the ampersand. Delete that and use string interpolation here. And what do we say? We say secret, what's it called? Build secret key, what is it called? Secret key dot app ID. That's what we're after. So we change in the hard-coded number so that's not visible. Because that particular test, it will be visible on GitHub. But we do not want to add our key there explicitly. So it's accessed via secret key dot app ID. We also want to do the same thing for app key. So after the equal sign, all the way down to the ampersand right before the from keyword, I use string interpolation again and say secret key dot app ID. No, app key, sorry. No, yeah, app key. Okay? Exactly, exactly. Next up, we have the query. Query says Christmas cookies. I want to take that hard-coded Christmas cookies out. And I want to string interpolate it and put in search query. No. No, it's just it's not seeing it. Build it, Command B. Command B. Mine did not see it. It took a bunch of Command Bs before it came up. So Command B, and verify that your secret key is a struct called secret key, right? Your secret key file. You might not have it. Let's go back. Let's go back and verify. Everybody, go on your secrets folder. Click on Secret Swift. Does your secret key file look like this? Right? So you should be able to access secret key now in your test. Were you able to access it? Great. Yeah, a couple build and couple Command Bs will work. Okay, so we have our expectation, we have our recipe endpoint URL, we have our search query. Great. Let's keep going. Let's pause for a second and go to the network helper. Somebody let me know what's different in my network helper. What's different in this network helper here? Anybody sees what's different in the network helper? May said it. May said URL request. That's different, right? What did we have there before? Right now we have a data type called URL request. What data type did we have before? It was a string, right? It was a string before. Before we had a string. Now we upgraded our network helper to accept a URL request. Okay? A URL request is able to have more information in it. A string only has a string. A URL request could have more information. It could have information about the headers, right? It could have a lot more information in there. So we upgraded the network helper to accept a URL request as opposed to a basic string. And if we look at our session data task also passes a request as opposed to a URL. And again, a URL request has more information. It basically allows us to package more information as opposed to a URL. Okay? Think of it as a small cup as opposed to a big container. A big container will have more information in there. We could put in more information, metadata that we put. Later with posts, we'll be able to see that we need the request to the post on Thursday. On Thursday, we will need this request because for posting, we need to go request body and put in our JSON body in the post. URL by itself does not allow us to package more information. Basically, the URL only takes a string. A request takes in more information that we need to send up to the web API. Okay? Good. Now let's go back to the test here and keep going. So let's create a request using URL request. And this URL request, we could pass in a URL, right? So other things you could pass into a URL request is the cache policy, like how long you want to be caching, a timeout interval, like maybe wait 10 seconds before you make a next request. There's a lot you could do there. So it's a bigger API. But the basic one we're going after right now is the URL one, just for today. And then here we want to pass in our recipe URL. Well, we'll create a URL. URL string, and we'll create a recipe URL there. What's the difference between, make sure you put an exclamation mark after our URL. What's the difference between? Yeah, the string is just a string. We need to create a URL. Exactly. Yes. Because our network helper takes a request, not an optional request. It doesn't take in an optional request. But this particular URL there, because it could fail, maybe it's not valid, right?
Is that the same? Wait, no, it's a query.
The source query is just like what we're looking for. Yeah. But now we're about to make our actual network API call. So we'll say network helper dot shared dot perform data task. It's expecting a URL request now. So we pass in our request that we built. And completion is result. Great. Great, great, great. So this particular would be the act part of the test. So we did a range. This is the act part of it. And now let's go ahead and switch on result. Switch on result. Case failure. Switch on result here. Case failure, bless you. Let app error. If we do have an error, we failed. So XCT fail. And here we're passing some message. So at this point, we failed. Something went wrong. So we basically just log it out. So app error. And we use string interpolation to pass the app error. Great. Next case, we were successful. We got back data. Great. Here we will assert. We'll assert here. We'll say XCT assert greater than. So data.count. Again, data is bytes. So we only want to confirm that the bytes we're getting back is greater than, how many bytes we have here? 800,000 is greater than 800,000 bytes. And here we'll say data should be greater than whatever came back. So data account. So we have our normal switch statement on the result, right? From our network helper. Our network helper has two cases. Either it failed or it was successful. If it failed, we log out an error. Our test failed. If we do get back data, let's see how many bytes of data we got back. Based on our Postman, if we go back to Postman, based on Postman, this is the amount of bytes we have. Do we all see size here in Postman there? Do we see the size part of it? This is the amount of bytes you downloaded, right? Here it says I downloaded 827 kilobytes of data, right? So I need to get more than 800,000 bytes, or else I failed. 800,000 bytes, right? So go back to my test here. This is what we're testing for, okay? And this is an asynchronous test. So the big difference between what we've done so far with unit testing, again, asynchronous test is not a unit test. It's not fast. It's not reliable. Could fail. There's no network. So here, the big things, the difference is, one, we have this expectation. Where do we use that expectation? We have to use the expectation when the success part of it is done. Here we'll say expectation fulfilled. Expectation fulfilled is basically like, I've gotten the data I want, now return to the caller. So expectation dot fulfill. This is the expectation we wrote on line 19. This is what I'm looking for success. So when I'm successfully gotten to the point in my data that I got back data, or I'm doing an assert, I say expectation fulfill. If I do not say expectation fulfill, my assert will never get called. Okay? If I do not say expectation.fulfill, my assert greater than, it will never get called. Yes? From the Postman. So if you go to Postman, our Christmas search for cookies. Tiffany, look up here. Over here, where it says size here. Do you see size? If you search for Christmas cookies, you get back 827 kilobytes of data. Do you see it on your Postman?
I see that.
Okay, that's why I got that number. Are you searching for 0 to 50? For Christmas cookies? Click send again. Did everybody get 827-ish bytes of data or kilobytes of data? I want to double check your query because you're the only person not getting that correct number. Double check your search is the same. Double check your parameters are the same. Okay, so let's keep going here. So make sure that you have a fulfill on your async call. If you don't have a fulfill on your asynchronous call, again, asynchronous, it goes, it does its work. I don't know when it comes back. But I know where to expect my fulfillment to be done. Okay? And we have one more piece to add to our asynchronous test. We need to say wait for a period of time. We need to give it a waiting time. We need to give it a waiting time. So we'll give it a waiting time right outside our block here. I'll say wait, I'll type in wait. And then wait, I pass in an array. And the array is expecting some expectations. So I pass in my expectation I declared earlier. Like waiting for what? What are you waiting for? I'm waiting for that particular expectation to happen. The timeout, how many seconds should you wait for? Is it 3 seconds? Is it 5 seconds? For our use case here, we'll say 5 seconds. So wait for 5 seconds. So go ahead, wait for 5 seconds. If I don't get my data back, I fail. With an async test fail, it's just going to fail. If it doesn't get data back in 5 seconds, this test fails. Again, it's not a unit test. It depends on things. It's an integration test. It's an asynchronous test. There's outside dependencies there. Yes?
So get the hard code, the numbers.
I could say more than zero,
So that would.
but in my case, I know how many bytes I'm expecting, so it needs to be greater than that's the number, or some number that I used. I just, yeah, I could put 600,000 in there, right? But I know I want to get back at least 800 bytes of data. Oh, the wait, 5 seconds is enough time to get back data. Yeah, 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 yeah. You gotta give it a timeout, right? Yeah, not user friendly, but you want it to fail after 5 seconds. You don't want it to keep going for 30 seconds, right? At this point, it should fail earlier. Okay, that's why it's not a unit test. It's not fast. This is not fast. 5 seconds is not fast. Okay, and cool. So let's go ahead and run that test. How do we run the test again? Command V. Oh yeah, Command U. So click on Command U. Click on Command U. It's an optional. Make sure you're on line 18. Make sure you unwrap it on line 18 there. You see line 18, we have an exclamation mark on query. Okay, so at this point, our test passed, or my test passed. Our test pass? Your test fail? What did it fail with? Some timeout, maybe? Right, so timeout. Make sure you have expectation dot fulfill on line 30 in order for the test to return, or in order for my completion to return. We need that on that test, explicitly, yes. On that asynchronous test, you need it. That's a requirement. It basically tells my test it has gotten to the success part of it. Go ahead and run my assert. I've gotten to my case success. Go ahead and run my assert. You don't see that print search found in that case here. If it fails, you'll get a different print, but you don't see it. That expectation is only for the wait. Only for the wait, that's where it's used. In the wait block there, where it says wait for expectation, nothing gets printed. Anybody got red? What's the error? 401. So that's an authorization thing there. You got a 401 error. Authorization. Make sure that your URL is the same as you have. Make sure your secret key is the correct secret key. Make sure your app key is the correct app key back in your secrets folder.
My timeout is saying that it can't be a double.
What can be a double?
This can go. Yeah.
Okay, how are we doing? We still have reds? Any reds? Chelsea? 165. Oh, well, it shouldn't be near. Double check your postman, by the way. Make sure you get more than 165 because there's more data than that. Cool. My postman. How are we doing with time here? Time just goes. Okay. Postman. I have 827. Cool. Okay. Okay, cool. I would do some test-driven development, but for this, for time, right? For time, we'll jump into the code. But know that if I had the time, we'd go and do a next test with test-driven development to test the model. But right now, we're just going to jump into the model, okay? So let's go into the model. We have a model folder. We have a model folder. We also have a model folder. Right-click on it and create a new file. Right-click on it and create a new file. So we tested our endpoint. We know it works, right? We know we have more than 800,000 bytes of data. We are good to go. Let's go ahead and create our model. And my model is called recipe. It's called recipe. I click on create. And let's go ahead and model this. So what does our JSON look like? Who selected the model? Anybody? Yeah. Anybody select out the model? This guy. We're going to create a model from our JSON. Okay? What are we interested in? So we have, what's the root level of my JSON? It's a dictionary. And that dictionary has hits. We saw hits, right? And then our hits, we have an array of stuff. Do we see that? Right? And in there, we also have a recipe dictionary. Okay? So let's go ahead and create that model. It looks like an array of recipe, but it's not an array of recipe. It's an array of hits. And then the hits itself has recipe. So let's go ahead and model that. So the top level, we'll call it recipe search. You like better what? Oh yeah, there's some JSON where you need some more work to do it. So we have hits, right? We after hits, and hits will be an array of hits, as we said. It's not an array. It looks like an array of recipes, but it's not. It's an array of hits, and then let's go ahead and do that. So we have a struct, and it's a hit, decodable here. And that hit has a recipe. So each hit has a recipe, called recipe. And what are we after for a recipe? For now, let's just get to the label. Recipe, decodable. And let's just get to our label. Label is enough. And label is a string. That's enough for us to test out, do we get recipes back? How many recipes should we get back if we're successful? 50, right? So that's a good test there. Cool. We wrote out the model? Good? Okay. So let's go create an API client for this recipe. And we have, do we all see network services folder? Do we all see network services folder? So network services folder has an app error. It has our network helper. So here, let's go create a new file. And we'll call it recipe search API. It's a Swift file. And we call it recipe search API. Make sure to save it into targets recipe search, not recipe search test, please. I did not, right? Recipe salad what? Right? Recipe search. Okay, API. Just API is fine. You could put client if you want. But the name is long enough for us right now. Recipe search API, that's good. Click on create. And we have our folder. Great. So let's start off. We have a struct here. It's called recipe search API. What are we going to call this? We'll call this fetch recipe. So it's a static function. static function called fetch recipe. Okay. At some point, we'll have a search bar so the user could search for any recipe by name. So whatever the user puts in here will be some sort of search query. So fetch recipe for search query, and search query is a string, right? And this is a network request, so we need a completion. What do we need here, Julia? I have a completion. It's a network call. It's asynchronous. How do I get data back? What am I writing there? What does my completion need? It needs a result, right? And it needs to be at escape in here, right? It's a closure. Doesn't return anything, but it captures my result, which is a generic. In our case, what do we capture? We capture an array of recipes. Sorry, let me fix my screen here. Take this out so we have more space. So recipe, or what? Recipe or what? Or app error. Great. You guys are rock stars. Okay, cool. So let's move to the test. Whatever we have in our test, we'll just copy it. Because that worked. That worked. Our test worked. Let's go back to our test. And I'll come right back. But go back to your test and come back here. Go back to your test. And what do we need here? So we need the endpoint URL. That works. We'll just grab the grab line 20 and line 22. So copy those two. Copy those two. And copy those two from the test we just wrote. Paste them in there. So the endpoint URL we need, that works. We interpolated it already. And we'll do a bit of refactoring. Like we're not gonna hard code, we're not gonna bang this URL here. So we'll actually do some cleanup. So I'll say guard let URL equal to URL string. And the string is the recipe, else completion, failure, bad URL. Yes, Julia? Question? We have our endpoint URL. We tested it already. We have a test for it. We get back data. Now we write our API client. We've guarded against the URL. Earlier in the test, for test purposes, we forced unwrap it. But here, we will safely unwrap that URL. And from that URL, we'll create a URL request. So if you want to continue on, next step is to create a URL request. Because our network helper now expects a URL request. So let's create one. So URL request needs a URL. We have a URL. Great. Great, great, great. What's the next step here? Next step is to call our network helper. Same as the test. Share dot perform data task. Here we pass in our request. And we have our result. We have our result. Whenever we see result, we know what's happening next. We use a switch statement on it. And we case on it. We say failure is let app error. In that case, we return some app error to whoever called us. Here, what do we want to return? Network client error, failure, the network client error, and we pass in app error. Great. If it was successful, we get back data from our associated value, let data, and now we use that data to create our array of recipes. Okay, cool. So we'll say do catch here, because we're about to use JSON decoder, and we know it throws an error. For now, I'll say results equal to try JSON decoder dot decode. What's our top level? Our top level is recipe search dot self and data. So here I'll change this to search results. What do we have on search results? So search results, if we type in search results dot hits, right? On every hit, what do we have? If I say first dot recipe, right? So this is how we access the recipes. Basically, we want a way to be able to create recipes. How can I create recipes here? How can I use my search results to create my 50 recipes? Should we leave that as a challenge? I think so. Come back on it tomorrow. So to do, use search results to create an array of recipes. Okay? And then after this, you want to capture the array of recipes in the completion handler. And then you want to write a test for it. So then after this, I'll come back to that, but go back to your recipes test and write a test here. It's an asynchronous test. So to do, write an asynchronous test to validate you do get back 50 recipes for the Christmas cookies search. Cool? So we have 3 to-dos. This is the third one. We're going to go back to the first one now. I also want to make sure people type out the to-do, and then I'll go back to the previous one. So let's go back to it now. And the first one is create an array of recipes. And second one, since you have that array now, it's a success. So just capture it in the completion handler. And I'll just type out the completion for the decoding error here. This is a failure, and this is decoding error. Right? So basically, we saw that we have an array of hits. We saw that, correct? And the hits themselves has recipes. So use some sort of logic to get back those recipes from the hits, right? We know we have, you guys know what you're doing. There's no hints, right? Brendan said you're good. And somebody's gonna demo that one tomorrow. I know I said on Monday we had to demo, right? Everybody came with the case of the Mondays. We did not demo our table view and our jokes, but tomorrow we'll get a volunteer, or I'll use my app to get a volunteer to show us, hum day, right? To show us the recipes. And somebody else will show us the test. So 2 volunteers or 2 volunteers.
We don't have a model yet, technically.
We have a model.
Yeah, but all we have is the, like, we don't have the, like, we have the name, what
We have a label. That's all we care about for now. The name of the recipe.
so that's all we need. So that's what you mean when you say the recipe, just the name, the label.
Well, what I mean is, do you have 50 recipes?
All we're looking for right now is the label.
Yeah, that's fine. All right. Yes, sir. Recipe model. Any questions? Cool. Go back to the network helper. Oh, the API client, you mean? All right. What part? The third one is the test. We write a test to validate that you have 50 recipes. Because the first test we did was just basically for data, but your test will actually test, do you get back 50 elements in your array? Cool? So you'll basically be testing this function here, the fetch recipe function. Cool? Up here. Sorry. So I guess for the test, 1 second. For the test, you are, to do random sequence test to validate, you do get back 50 recipes for the search from the fetch recipes function. Okay? This is what we tested. Okay. Anything else, Julia, you wanted to see? API client? Which part? Is it? Okay. For the last test, for the third one, basically you want to test this function, the fetch recipe function. That's what you tested. Fetch recipe function. That's it. That's what we tested.
And I want to see this function.
Yep. And again, it's a asynchronous test. So the big things you need for your test to work, you must have an expectation fulfilled. You must have an expectation variable, and you must have a weight. So very similar to the first test we wrote there. Parts of it, you need number 19, you need number 28, and you need number 30 in order for your asynchronous test to work. Okay? And you put your fulfill where you expect that success to happen. You put your weight outside of the block of everything, what period of time you want to wait for. And the expectation description could be whatever you expect. In my case, you could say 50 recipes found or whatever you want to do. Whatever string you want to put in there is up to you.
You said 19
Required for async test 19, 30, and 35. You have to put weight. Yes. All right, cool. Or is it just going to return right away? It will fail. All right. Good question. Any other questions? We did a bunch of stuff today. The highlight of the day was really talking about getting an API key and putting that API key in our code to get the data we need. And also we spoke about hiding your API key from the public. So we spoke about the getIgnore file. So now anything you want to hide on GitHub, you put it in the getIgnore file. Other things we'll talk about at some point, maybe not exactly today, but I want to talk about, here we're using string interpolation. Here we're using string interpolation to build endpoint URL. But there's a next way to do this using, I'll put a to-do there for myself, or fix me, or something, or later. Later, we will look at URL components and URL query items. Right? That's a more friendly way of writing your URL endpoint. It's very similar to, for example, it's very similar to what we do in Postman. So there's a key value. With the components, there's a key value. The key would be Q, the value would be whatever the search query is. A next key would be API key. A next value would be whatever your API key is. Everybody with me? So the first way we saw was string interpolation, where we use a string and we interpolated all the params of the API. A next way we'll see later is using URL components and building it using URL query items. Okay? I don't want to show too many things on the same day, right? Even if it's in my head and I want to take it out, but there's a limit. And I think we've gotten to that limit. I see Lydia's eyes is like, cool. So we'll see what that looks like later, right, Julia? As we get more comfortable with using string interpolation, we'll talk about URL components. Okay? Cool. Any other questions? Why is the window so open? Okay. The window guy. Yes. For hours, we know it's 827. I didn't want to be exact with the number. So I said more than 800,000. Yeah, you can. If you're downloading some image, like normally you want to test a particular piece of code, right? If you're downloading like an image of a tree, you know how many bytes you should expect, right? It's almost like when, what's it called? There was a Windows, I haven't been on Windows for a while. There's a checksum, like an MD5 checksum, whatever it is, to see if what you downloaded crosses with what you expect. And then that's a successful download. Does that make sense? So you have an expectation of how many bytes you should download, and you make a cross-check. Is that equal? Right? Because an image, if it's 10 megabytes, it shouldn't change on somebody else's machine. 10 megs is 10 megs. See what I'm saying? So you can make a test there, downloading the same asset. Cool? Like a song, for example. If it's 200 megabytes or 255 megabytes, that number doesn't change unless you compress it or something else. Cool? All right, great. Any other questions? Great. So we know we could structure our code the same way like we did today. If you're creating like your own project, you start off with having like network services where you have an app error, you have a network helper, and then you have some sort of extensions for images. If you're not working with images, that's great. You don't need images. But if you're talking to the internet, those are the things you need. You need an app error that captures your error states, and you need some sort of network helper that returns you some sort of data or error. Okay, that's it. With that network helper, I could get images, I could get my recipe model created. Cool? Great. All right, so I'll stop here, and we'll continue off tomorrow. And somebody's going to volunteer. Yulia, is that you? Yulia volunteers right now. Thank you. Cool. See you.